Yo, what's up internet, Sins Media here, and we are back in Lua Protoplug today. I've just been making a little wavefolding oscillator, and I would like to show you what it does and how it does it, how it works. So the best way to explain what wavefolding is, I think, is to just try to show you on this oscilloscope here. Unfortunately, it glitches slightly. It sort of stops or jumps around a bit, but hopefully you can see what's going on. I'm going to play a very low frequency. Currently this is a sine wave oscillator, so you can see it's doing exactly as you expect a sine wave to do. This jumping around is just a glitch in the oscilloscope. Yeah, like that. So imagine I have a threshold value somewhere between 0 here and the top of this wave. Now, and what wavefolding does is when I get, let's say the threshold is there, any part of the signal that goes above that, instead of going above it, it's going to kind of do the mirror image. It's going to start going down. Now, watch as I start turning the wavefolding up. You'll see that the peak is cut off this sine wave, but it won't just go flat like we're making a square wave. It will start to reflect downwards. Now the same thing, so here's the threshold at the moment. Instead of going to the top, it starts going in, and the same at the bottom. Instead of going all the way to the bottom, it starts to fold back up again. So that's the basic principle of wavefolding. Now when it's a pure sine wave, you'll get that sort of pure tonality. The more you add the fold, obviously you're adding a sort of double peak here, and that's introducing new harmonics. So as we increase this parameter here, that fold is going down. It's going to continue going downwards. Now we're getting close here to so the threshold is reducing, but we're getting close here now to the threshold being more or less the 0 point. Now what this does then is it starts to bend back up again, or fold back up again. So we get to there, and now we're introducing even more harmonics. Now, some wavefolding algorithms, when this starts to turn up here, it'll start to fold back down yet a third time. I've decided, partly for simplicity and partly because I quite like the effect, that it's going to simply clip if it goes above the value gain, and so it starts to turn into a square wave at this point. So now it's a full square wave. So you can hear what that wavefolding does. I think it's giving us quite a nice sounding and quite interestingly complex sound at this point. So let's have a look at how that algorithm is implemented, and it is really not that complicated. This is the same code base that we've been using for our other noisy square wave synthesizer in Protoplug. The only difference really is in this next function. Now if you remember the next function, when we're filling our buffer of points to generate the sound, the next function is simply giving us what's the next value. Now just as before, we've got this value within our oscillator that's the phase, and we start off our function by calculating the sine of the phase. So that's giving us, inside the variable s, that's giving us our basic sine pattern here. So what do we do with that s value? Well, we've got this variable v. If the S is, and we've got a threshold, okay. Now, if you remember, when we go, the threshold is set to here. Anything above that will fold down again. So this point in the threshold is here. Anything above it is folding down. So if the S value, the sine value we calculated, is greater than the threshold, then what are we going to do? We're going to firstly calculate by how much it's above the threshold, the difference from the threshold. That's what this expression here, S minus threshold, is giving us. So let's say the threshold was 0.8 and the S value was 1, then 1 minus 0.8 is going to give you 0.2. That's the difference. So we're now going to subtract from the threshold, which is 0.8, that 0.2 gets us down to 0.6. So instead of being 0.2 above it, 0.2 below. It should be fairly straightforward what's happening there. And it just does that all the way through, down to that point. Then we come down to this clause here. Now, if it's fallen, as it's folding down, if it falls below 0, then we simply negate it. So the V value, if it got below the if it gets below 0 there, starts to fold back up. So if V is less than 0, V equals minus V, push it back up again. On the other hand, if we're not at the top here, if the calculated value is down at the bottom, then we want to do the same thing in the kind of reflected, the mirror image of it. So if S is less than the negative threshold, then we calculate the difference again, we add it to the negative value of the threshold, and again, if at this point we've gone above 0, we do the second folding and come down. So this does exactly what we would expect. That's first degree of folding, second degree comes in, and at this point we've got a value for V, which is, otherwise if it's not over the part that's being folded, it's just going to be the calculated sine thing. So that's what V is here. Now if you notice, normally as you started taking this threshold down, the wave would get smaller, it means it would get quieter, so we want to compensate for that. And this bit of code here, we calculate 1 over the threshold and we multiply that value by that. So that basically just compensates for any loss of volume as we're reducing the threshold, and that goes into this variable called final. Now if final is greater than 1, then we clamp it down to 1, and if it's less than -1, we clamp it to -1. In other words, we now just clip it absolutely. That is giving us the last bit of this algorithm. As we keep going further, we hit this limit, it gets clamped to this limit, and if you do that long enough, it's just going to become the square wave. If you remember the previous version of this oscillator, that's how we made a square wave. We simply clamped over a certain value. So it's nice. It's a nice effect. It's actually giving us 2 effects for the price of 1. In a sense, it's giving us a wave folding, but it ends up being shaped from sine into a square. Okay, and that's it. That's really all we need to say about that algorithm. The rest of this oscillator is more or less the same as it was before. Now, the only interesting thing now about this synthesizer is that, if you remember, we have an LFO which is doing amplitude modulation. In other words, a low frequency version of the oscillator multiplied by the main one to vary that. Now, the previous versions of this synthesizer, that was a square wave oscillator. The low frequency oscillator was also square wave, so it was more or less just turning the main wave on and off. Now though, it's a sine wave, so it has a slightly more interesting effect to it. So let's just see what happens if you put that up a little bit. Right, we'll put the frequency up a small amount, put the amplitude up a lot more. So now the amplitude of that wave is oscillating at this frequency. Take it up. It's amplitude modulation, but as we take this LFO frequency up into the audio range, it starts to dominate the pitch of the thing. I'm going to turn the volume of this up as well. So that's the same as we had before. The LFO is amplitude modulating the main wave, but now it's itself one of these. So as it is now one of the same oscillators though, it also can do wave folding. So as we take this up, we can now do the same thresholding and change the shape of that wave. So this now starts to give us even more complexity in our sound. Let's turn that a bit more. So now we really want to hear this. At this point it's become a square wave. Let's take that frequency down again, and you can see it's having the effect of simply turning that on and off. Turn the frequency up. Turn its own wave folding down. And of course, we can now turn the wave folding of the original wave back up. So we really have now a very rich and fairly complex oscillator. Fairly simple algorithm to do it. I mean, fairly simple algorithm to do it, given that we've written the rest of this in the previous tutorials. So just that has given us this really nice, interesting thing to experiment with. So, and of course we still have our filter, our low pass filter. We'll turn the resonance of that up. Turn it down, we'll lose all those high harmonics, of course. So let's just turn, I've got a couple of formula controllers here that are turning on some of these values. So this one is controlling the wavefolding itself. So the next one on. That's the LFO threshold. We change this. And then finally I've got this one hooked onto the cutoff. Let's put it through some overdrive. Maybe some chorus as well. So yeah, this is it really. I think there's nothing more to say about this. It's a nice oscillator. It's interesting, and I will make it available in the description. And thanks for watching, and I will be back with more proto-plugging and other coding synths in the near future. Synths Media, and I'm out. God, this is just such a boring end, isn't it?